Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay, back with yet another Algebra 1 video for you all. And today's lesson topic is all about standard form, our quadratic equation, our next one up from our Vertex form that we covered in our previous video. So make sure to check that out before coming into this video. And this is going to be the continuation of our quadratics unit here at the very end of our Algebra 1 course. So make sure to stay in tune. This is stuff that's going to be very important when you get into Algebra 2 after geometry next year. So it's really useful skills, and of course you're going to revisit these skills and literally just pick up right on where you left off from Algebra 1 all the way to Algebra 2. So what are we covering in this video? Before we get into that, please make sure to do 4 things. Please make sure to smash the subscribe button, hit that like button on this video, turn on post notifications, and drop a comment down below. So the meat of today's lesson is going to be focusing on just exactly what the standard form is, how you get comfortable with the standard form, what are its different properties, like what are all of those variables there, a, b, and c, and x squared and x bar. There are 2 forms of x. So we're also going to be showing you how it represents a parabola and what its basic characteristics are when it comes to graphing and also its equation. So without further ado, let's jump right into it. So standard form. What exactly is standard form? Standard form is merely a quadratic form of a quadratic function. It's a way of expressing a quadratic function that's written in expanded form to represent a parabola, a function. And this very specific equation provides us with the y-intercept of the equation, just as the vertex form had its special properties of providing the coordinates of the vertex. Standard form and vertex form can actually be switched through computation. They're interchangeable with each other. And also standard form is used to help in specific scenarios. So we know vertex form and standard form. But of course, when it comes to certain problems, it has to do with trajectory, like finding your starting point, like your y-intercept, or instead you want to just go straight to the vertex and discover like a maximum or minimum. Your vertex form would work, whether your standard form would relate better with your y-intercept because it's literally given to you. They have their own little perks, so you have to make sure that you're not wasting your time and identifying which form is best for you. So let's take a look at the simple features of standard form. So let's identify what the different components and variables are, just like we did with our vertex form. So this is the equation, ax squared plus bx plus c equals f of x, or in this case, it's more commonly written in terms of 0. That's just basically your placeholder, but I'll explain this and how this will actually relate in terms of your quadratic formula later on in this course, and of course in our quadratics unit. So let's start off with a on the left-hand side. We know what x squared is. So a is the constant multiplied with x squared. If we revert back to our vertex form, it's the same exact a that's being multiplied to that x minus h squared, that little parenthetical expression there. It's your stretch factor. It's what's determining how wide your parabola is, and it's not changed in any way in the standard form. And of course, we go over to b, our next variable. This is the constant that's being multiplied with x. So it's going to be a constant term, and it's multiplied with x. So x happens, x is built once you start to expand your vertex form equation. You get rid of those parentheses, but I'll explain that, why you have an x squared and an x in the next slide. But it's the constant that's multiplied with x, the single term x, not the x squared, and it pulls, essentially the property is on its own in terms of the parabola. It's what actually pulls the parabola off of the y-axis, gets it to stretch out differently than the h. The h is just a solitary movement, moving it up a certain, just like you would essentially move left or right on the x-axis to move away from the y-axis. This has to do more with the gradual stretch, with the magnification of b, meaning the larger it is, the more it's going to actually impact the stretch that the parabola is going to have. And then, of course, we have our x. X is merely just going to be your x coordinate in place of your x squared and your x. And finally, we have c, which is, of course, the y-intercept of the parabola being added to that whole entire equation, ax squared plus bx. It's just like you would in a linear equation, adding that b at the end of your equation, your linear equation, y equals mx plus b. You're doing the same thing with c. And of course, 0 is just in place of f of x or the y coordinate, f of x being the same thing as your y coordinate. I'll explain why exactly we do that in our later videos in this quadratics unit. Excuse me. So now let's take a look at a very important comparison. Let's compare the standard form versus the vertex form. So what is the relationship? So standard form and vertex form, like I said in the first slide, are computationally interchangeable. That means you can change in between both of them and they actually represent the same thing, the parabola. Standard form is actually the expanded version of the more compressed vertex form that is a squared binomial. If we revert back to the vertex form, which I'm sure you're more comfortable before getting into this video, obviously the vertex form is written in f of x equals a times x minus h, in parentheses x minus h whole squared, and then plus k. It's much more condensed, as you can see. It's literally a squared binomial. So what you're going to do with the standard form, you're literally going to take that binomial and that square, and you're literally going to expand it, get rid of those parentheses. So you're going to multiply that term by itself because you're squaring it. You're multiplying it by itself. So you're multiplying binomial by another binomial to get, overall a trinomial at the end, which is your standard form equation. So let's take a look at what exactly that, what I mean by that and what the conversion is. So we take a look at our equation here, y equals x minus 2 squared plus 3. Of course, we don't have an a value. That's just going to be 1. And this is our vertex form. So how exactly do we convert it? So the first thing that we're going to do is we're going to take away that squared. Remember, squared is merely when you multiply it. When you're squaring an item, you're multiplying it by itself again. So you're taking that x minus 2 being whole square, that whole expression, and you're multiplying by itself. So x minus 2 times x minus 2 plus 3. And then, of course, when you simplify that, you can essentially FOIL it out, just like you've learned in our previous unit in this Algebra 1 course. You're going to start from, of course, using your FOIL, your outer and inner terms, you're going to order them. So let's start with x and the x. So x times x is x squared, obviously, and then negative 2 times x, and then another negative 2 times x, that's negative 4x. And then finally, you're left with your constants, your negative 2 and your negative 2. So negative 2 times negative 2 is going to be 4. And then, of course, you're adding that 3 on the right-hand side, your c value, and that's going to be 7. So it's x squared minus 4x plus 7 as your final answer. And this, of course, is you're hinting at your standard form. Your obviously, just like I said, your ax squared plus bx minus bx in this case, but plus bx plus c. That's the same form. All right. Now let's take a look at a very important skill. So we're going to move on to identifying the components of standard form by identifying how exactly we can graph using standard form. So how to graph in standard form. We're given this equation here, y equals 2x squared plus 4x plus 3, and we're tasked with the with the itinerary essentially and the agenda of graphing it, showing you the whole process of actually turning this into a parabola with at least 3 points minimum to create that parabola. So we're going to take this equation and we're going to start with step 1. We're going to find the axis of symmetry by using the formula. Now you might be thinking, why are we finding the axis of symmetry and why do we need that formula? Well, I'll explain that next. But first, let's focus on the formula for the axis of symmetry. So in order to find that axis of symmetry, literally the center of your parabola, so that if you take the axis of symmetry, put it right in between your parabola, both halves will be identical. So it literally splits your parabola in half. In order to calculate for that, there's a really neat formula, which is negative b over 2a, taking those parts of your equation. We know that our b value is going to be 4, so it's going to be negative 4 over our a value, ax squared, and y equals 2x squared. That's 2 is going to be our a value, so we're going to multiply 2 by 2. That's going to be 4, doubling 2. So now we're left with negative 4 over 4. And that, of course, is simply negative 1. Now we know that x is going to equal negative 1 in this case because your axis of symmetry when it comes to your traditional parabolas, especially in Algebra 1 and Algebra 2, they're always going to be, specifically Algebra 1, they're always going to be your x-axis. Remember, x-axis is representative of a vertical line and our axis of symmetry is vertical. So just as I was saying, this calculation gives us the x-axis of the vertex, since the axis of symmetry intersects the vertex and it is always a vertical line. So it's going to be an x equals no matter what. And also it intersects the vertex. Not only does it intersect the center, we know the vertex is at the very center of the parabola. So it intersects the vertex and helps us try and discover the vertex. The vertex is always where you want to start when graphing your parabola. It's the easiest way to start. So just like I said, you have a regular parabola. You're creating that axis of symmetry, splits that parabola directly in half. And that's always going to be an x equals whatever number because it's a vertical line. Excuse me. All right, so now continuing with graphing in standard form, we're going to take that same equation and we're going to advance what we have already. We figured out the x-coordinate of our vertex since it's going to be the same on that same, essentially, that same vertical line there. It's going to have the same x-axis. X-coordinate. So now we're on to step 2, which is merely finding the y-coordinate of your vertex by using the equation. So since we know our x value that we're looking for and we want to find the correlating y value, we're just going to plug in our x, our -1. So we have y equals 2 times -1 squared plus 4 times -1 plus 3. If we do the simple computation, mental math, we're going to take -1, square, that's going to be 1. So we're left with 2 times 1, which is 2. And then, of course, 4 times -1, that's going to be -4. And we're adding that to 3. So when you have 2 plus -4 plus 3, you're going to be left with y equals 1, positive 1 here. So once you're left with y equals positive 1, you essentially now created your ordered pair. You now know that your vertex is -1, 1 after calculating with your axis of symmetry and finding the correlating y value. So you can now plot this on your graph and begin to build up off of your vertex. We discovered that our vertex, after aligning that essentially with our axis of symmetry, we found the y value and we identified the exact point of the vertex. So now we can start to build up and graph our parabola. So we're taking that same equation and we're moving on to step 3. We're going to find and graph 2 more points on the parabola. Remember, you always need 3 points in order to graph a complete parabola. So all we need to do is find and graph 2 more points on the parabola, including the y-intercept 0, c. Remember, we already know how to calculate for the y-intercept on the standard form. That's the literal highlighted, one of the highlights of the equation. You automatically know what the essentially what the y-intercept is going to be, your c value, 3 in this case. So now you've not only found 1 point, but you've already automatically found 2 points, and now you're just calculating for a 3rd point. So let's graph our existing parabola. We'll obviously start with our vertex at -1, 1. Then, of course, we have 0, 3, our y-intercept. I apologize, the graph was a little bit moved here, but this should essentially be aligned with your y-axis. I apologize, but this is essentially where your graph should be intercepting. This y-axis should be intercepting your parabola. And then, of course, on the left-hand side, the easy way to calculate the next point is taking your y-intercept and calculating an equal distance from left to right. Now, we're going to keep that x the same, 0. We want to keep it aligned. So all we're going to do is calculate the difference of the y-axis from 3 to from the x-axis of the x-coordinate from -1 to 0. And then we're going to go leftwards in the opposite direction. So we know that -1 to 0, it's going to be 1. You're literally moving from your vertex to 1 point on your x-axis across to get to your 0, 3, your y-intercept. So you're going to do the exact opposite move, -1 in the left-hand direction. And then you have the equation, the coordinate of -2, 3. It's the exact opposite distance from the vertex as 0, 3. That's why it's very important to find your vertex. You can literally discover any other points on your parabola with your vertex, so it's always important to calculate for that. And then, of course, the last thing to do is always graph your axis of symmetry. Now, I know a lot of classes and a lot of your teachers actually even require you to put your axis of symmetry, so always do that at the end. I know my Algebra 2 teacher and my Algebra 1 teacher, they mandated that you put your axis of symmetry down the very center of your parabola once you're done with it, even if you know what it is in your head. It's always just a requirement just so that you understand where that axis is, where it starts and it ends, and how you actually created it with the graph. All right, so now let's do some simple practice. We're going to do a practice problem that concerns fountains. Simple enough. So we're essentially going to calculate for which fountain has the highest trajectory. So we're given fountain A, and we're given the equation. We know that when it comes to trajectory, it's essentially a fountain that's shooting in the shape of a parabola. It's going up and down, and that's your simple trajectory, your parabola. So fountain A has the equation of its parabola listed. It's f of x equals -x squared plus 2x plus 8. And then, of course, we have fountain B, except that fountain B this time is a little bit different. it's written with a set of coordinate points like -6, 5, -5, 8, -4, 10, -3, 8. Negative got cut off a little bit, but it's -2, 5 as the last point. So when it comes to fountain A, the first thing that we're going to do is, obviously, since we're trying to find out the highest point on the parabola, we want to calculate the vertex, the maximum. We know it's going to be a maximum point because this trajectory, it's moving, it's downward facing parabola. So we're trying to find the maximum point, which is also the vertex in this case. So the first thing we're going to do is in order to calculate for the vertex, obviously we're going to use our axis of symmetry formula. So we take our b value, it's negative b over 2a, so -2 over -2. We take -1 and double it, and then of course -2 over -2 is equal to 1. And finally, we're going to plug that back into our equation to find the y value for vertex. And remember, when it comes to your maximum and minimum values, it's actually, I know you notice that the vertex is at the same point as that maximum or minimum value. In this case, if it's upwards or downwards facing parabola, but it's always the y value that actually matters in determining the maximum or minimum, because it's a vertical outlook essentially. So your y is going to be the most important, and the y is actually the only thing that you're going to put in your answer. So once we calculate for y, the only thing we put for is the answer is only going to be in terms of y. So now we're left with f of x equals -1 squared plus 2 times 1 plus 8. And we're left with that our y is equal to 9 feet. -1 squared is 1. 2 times 1 is 2. We add all of those together, and we're left with 9 feet. So now when we add all of that together, we get that the final answer is y equals 11 feet. That's the highest point. We have -1 squared is 1, plus 2 times 1 is 2, plus 8. That all adds up to 3 plus 8, which is 11 feet. And then on the right-hand side, we have fountain B, which is a list of points. But remember, the most important thing to discover is to find any types of unique points with the y coordinate. Now we notice we're looking for the maximum, so we're trying to find the highest value of y that's given here. You can see here everything is 5, 5, 8, 8, or 10. And we notice that the vertex itself, the y value for the vertex is only repeated once, always. So we notice that 10 is only repeated once for the y coordinate, and it's also the highest value. So that's got to be our maximum, our vertex. And obviously, because -4, 10 has the largest y, this makes it the vertex, and this also gives us exactly what we need, the y value 10. So we know that our height here is going to be 10 feet, and now we know that our fountain A is actually going to be the largest, has the highest trajectory of the two fountains. And finally, we're going to be looking at problems using the y-intercept with trajectory problems, just summarizing these types of problems. So oftentimes we'll come across a trajectory problem, which oftentimes when something is thrown, which obviously occurs oftentimes when something is thrown or takes flight at an elevated height. So think about, taking a ball. It's starting from your hand, you're throwing it up, it's going to be an ellipse, just like a parabola, and it's going to stop at, literally drop on the ground. And obviously those heights are going to be a little bit different. Therefore, it's going to be something with a trajectory, an overall trajectory that's abnormal. And also, if you think about a flight, a plane taking flight from an elevated position, it kind of goes up in the air. It's a little bit less of a traditional parabola, but we always use parabolas to kind of give like a line of best fit, kind of like a graph of best fit to identify where it's going to land. And you can calculate for the starting point of those objects by using C, your y-intercept, essentially where that starting point is on your y-axis. You can calculate the maximum, the highest point that it will go by using the vertex, just like we did in the previous slide. And also you can calculate the landing point where it hits the x-axis with the equation itself, the standard form equation. And oftentimes that'll look just like this, a little bit of an incomplete parabola, and it's not going to be a perfect parabola all the time. Oftentimes when you're flying, it's not a smooth curve that you're going up and down, but of course we can create a parabola that essentially gives a graph of best fit and identify all of its characteristics thereof. Alright everyone, I hope you all enjoyed today's video. This is in the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below, and also feel free to leave a comment and turn on post notifications. Check out our website, www.ecoreacademy.org. Email us at eCoreAcademy@gmail.com if you have any questions, and check out all of our socials, Pinterest, Facebook, Twitter, Instagram, and TikTok. I had a blast making this video, and I hope you guys found this useful, and a constructive use of your time. This has been AJay, and I'll see you guys in the next one. Peace.